Welcome to Rewired Logic. Today I'm going to walk you through a real-world fault diagnosis and repair that I performed in the field using the same proven principles and flowchart techniques that I've shown in a previous video. As I approach the control valve, my initial assessment involves looking, listening, and inspecting the setup to ensure everything is as it should be. My initial inspection didn't reveal much, so the next step is to pinpoint where the fault lies: pneumatic, electrical, or mechanical. I start by toggling the counterweight on the leaf spring. If the valve moves, the issue is upstream from the pilot valve. In this case though, it doesn't, which leads me to suspect that the pilot valve is the culprit. I removed the pilot valve, but only after isolating the supply air and bleeding the line to release any stored energy. As you can see, there is a bit of water and moisture that came out of the pilot valve. I have replaced the faulty pilot valve with an overhauled and tested unit. Now I can restore the supply air to confirm my diagnosis. The valve is currently in the open position because the SCADA system output is set to 100% open. With the pilot valve successfully replaced, I move on to calibration checks. I disconnect the signal cable and hooked up a loop calibrator, giving me direct control of the positioner signal. Then I perform an as-found calibration check to identify any parameters that needs adjusting. It is clear that the span is off by a significant margin, but before adjusting the span, I start with the zero calibration. When you do a zero calibration, you should hear a slight air release when toggling the counterweight and see very little to no movement on the cam or positioner. On the pressure gauge, the reading should be less than the supply pressure, but not equal to zero. To test the zero calibration, toggle the counterweight in both directions. In the closed direction, note how much air is being released, the pressure before and after, and ensure that there is minimum movement. In the open direction, the behavior will differ slightly, but the final settled pressure is what really matters here. Next step, we will focus on adjusting the span. After each span adjustment, it is important to perform a zero calibration check. This process involves a bit of trial and error, so repeat the steps until you achieve the desired result. Similar to the zero calibration, I like to confirm that at 100% output, when I'm toggling the counterweight in the open direction, it should release a small amount of air but cause very little movement. Here you can see me using the loop calibrator to check how far I am from reaching the desired span position. Now I'm back to adjusting the zero position, and I'm moving it so that I can demonstrate to you how it works directionally. At 19 milliamps, you can see there is still a very small but noticeable movement achievable in the open direction. Let's do another quick test at 19.5 milliamps. Now I'm running it through an automatic span check. Let's do a manual span check at 1 milliamp increments. As you can see, I still need to do a final zero calibration and a final span check. Now let me show you another way to toggle the pilot valve. This method only works when the signal is not at 20 milliamps, in other words in the open position, or if the cable signal has been disconnected. I think I'm done, but I'm going to get the operator to control the valve in manual from the control room, and a bit of patience is required for these steps.
Yeah mate, if you want, can you please take it down to 50? Mate, can we please have 0%? Is it blocking you from doing a 0%? that's definitely 0. If you don't mind, can you put it up 25, 50, 75 and then 100?
Thank you for watching the video. I hope you found it entertaining or useful. Don't forget to like and subscribe.